This is part 14 in a series of videos in which I am repairing and restoring a number of Intel MDS units. In this video we'll be looking at one of the floppy drives. Again, I've got a number of these to repair. I've started with this one because it's in by far the best condition. As we go through them, I'll pick them in increasingly worse condition where they need more and more work doing to them. So firstly, they're very simple devices. The only thing to bear in mind with them is before you take certain parts off, make sure that you can put it back on exactly where it came from. The real crucial part on this is the lead screw assembly. It's not particularly critical on this machine, but it is still fairly important that you put it back exactly where it came from. So firstly, there's a mounting plate and there's a bracket that allows you to rotate the motor relative to the mounting plate, and that does of course have a bearing on the absolute positionability of the lead screw, because you do have finite step size on the motor, and so if you do rotate the motor relative to the base plate, you will upset that fine positioning. And it is quite precise. You need to get it quite close to where it came from, so unless you need to, I advise you don't take the lead screw out. If you do have to take the lead screw out, try to take the entire plate off. And what I normally do before I take these plates off, assuming the drive works, is I would drill 2 holes for locating pins, and that way I know that when I put it back together again, I can get it back in exactly the same place. If you don't do that, you could have a problem trying to align it. If you don't want to do that, the next best solution is to make sure you have a proper alignment floppy disk. So alignment floppy disks are just standard floppy disks, except that the tracks have been laid down in very precise positions. So it's basically a standard positional track, if you like, and that way what you can do is adjust the mechanics of your drive, looking at the raw data, that's the raw flux data coming out of the head, and making sure that you optimize that for peak output across the entire disk, and that way you can be sure that it will line up correctly. And of course, be careful not to damage the heads. They're not particularly sensitive on these particular drives, but even so, you need to avoid hitting them with anything or scratching them. The rest of it is fairly straightforward. This drive's exceptionally clean, so all I'm going to do with this is take a few of the parts off so I can get to it a bit more easily, give it a good clean, make sure that everything's tight. I will take the PCB off so I can properly examine the belt and the drives. I'll give the PCB a good clean. So again, there's some fairly small signals going on around here, so I need to make sure this is properly clean. And in this particular case, the bearings seem fine. I'll check those more carefully once I've got the board out of the way, and the bearings on the motor also seem fine, but if they need attention, I'll deal with those as I come to them. No real corrosion on this particular unit. It is just going to be a case, I think, of cleaning it, and then we'll be able to test it and see if it works. Of course, if it doesn't work, we'll have to repair it. But I'll get on and get this taken apart as far as I'm going to, and then we'll have a look at the board once it's been removed. So I'll start by taking the side guard off. I'll now take this front plate off. That'll just give me better access to clean the side cheeks. Okay, that's the board removed, and we can now examine the belt in a bit more detail, see if it's got any nicks or kinks or marks in it. Now these belts shouldn't stretch, they're corded belts, so if you go right around the entire belt and see if any part of it is elastic, if it is, it needs replacing. This one seems fine, and again the bearings are fairly quiet. I'll lubricate them anyway, but they don't sound like they need replacing. The rest of the drive looks fine, needs a good clean, but other than that seems to be in good condition. All the wires are fine, there's sort of no nicks or scrapes in them. So I'll check everything's tight. I will take this out and give the fan a good clean. But that looks fine. And then back onto the top. So the only thing I'm going to do on the top now is take this top cover off. We'll check the top support drive. We'll clean up the lead screw. I'm not going to take this out unless I need to. I'll take the filter out and clean that, and then lubricate the motor bearings and give it all good clean, and it can then go back together. So overall it's looking to be a fairly good drive. So I'll get this cleaned up and then we'll get back on camera and look at reassembling it. Okay, that's all cleaned up. It's cleaned up quite nicely. There was no real corrosion or serious grime, it was just really dust, and I've given it all a very good clean. I've cleaned and lubricated the bearings, so it's now running very nice and smoothly. It should be totally silent when it spins. It shouldn't make any noise whatsoever. So I've lubricated both the head bearings and the motor bearings. Obviously if you do that, don't go overboard, you don't want any of the lubricant coming out. And the rest of it was just really giving it a good clean and making sure there were no sort of braided wires or scuffs or corrosion anywhere. So that's now all working fine. The main pivots were a little bit tight, that's these two pivots here, so I've loosened those and adjusted them, so they're now nice and free without any slack at all. And so the next thing is to get it all assembled. So first thing is we'll pop the mains filter back in. Relocate the power connector. Okay, I've cleaned the springs. There was a bit of rust on them, but what I'll do now is refit the rear side cheek. So it's spring first, and then the side cheek goes on. The wire back into the support guides. And we need to make sure the spring is sitting properly in its recess, otherwise it can, almost certainly will pop out. Okay. Next we need to refit the front panel. And we make sure the bottom edge of the front panel is aligned with the bottom edge of the drive. And next we fit the finger bar. Now we check to make sure that the mechanism operates the way it should, so it engages when it goes down, press the release and it should pop up. There's a damper pad under here, so if it makes a loud clank when it comes back up, that might need adjusting or replacing. This is fine. Now put in the securing cheeks. Okay, snug those down. They do not need to be particularly tight. And we'll give it another test to make sure it's still working. And that's fine. Next thing is to get the cone support on, and need to make sure that this cone is perfectly clean. Don't lubricate it, it just needs to be clean. That's fine. Okay. Of course, I've given this a very good clean, making sure that the spring's intact and that it gives even pressure all the way around, and that of course should engage cleanly with the metal cone. It should go down and it should pop up again when you release the drive, which it does. Self-centering, but even so, to initially put it on, pop it right down, put the spring on, and again I've de-rusted this spring as well. On with the top cover, making sure it engages with the spring. And then we just need to refit the two clamping bolts. Okay, and again make sure it releases cleanly without sticking, which is fine. Okay, so that's working fine. I've cleaned the heads, I've cleaned the lead screw, I've made sure that the head load mechanism is working the way it should. But the way this is supposed to work is when the solenoid is de-energized, there should be clearance between the head and the head pad, and then when the solenoid comes down, then this should be lowered onto the head. If not, it will need adjusting, but as you can see, this one's working fine. You don't want it rubbing on the disc all the time, otherwise it will damage the disc. If it does need adjusting, that's what this screw here is for. You want just a small amount of clearance. There is a specification for this. It varies slightly between certain drives. If this has been bent or if it's worn, it might need adjusting, but as you can see, this one's fine. Okay, next thing is this side cheek. Okay, that's done. Stops and other parts that aren't lubricated, they're just meant to be loose, so don't lubricate them, they'll end up sticking. They should slide freely, and as I say, if you put grease on them, it just ends up collecting dirt and it could get onto the disc and damage the disc. But they are designed to run dry. They're basically very loose in there, and that's the way they're meant to be. Okay, the rest is fine. I've gone over and checked all the wiring, made sure there was no shorts, scuffs or damage to any of the insulation. As far as I can tell, all the adjustments are correct. The the home stop flag goes in through the slotted sensor. I've also cleaned the sensor for the index hole detection, so that's in theory all working fine. So the last thing to do is refit the board. I've given the board a very good clean, so that's now ready to go back in. Clean it both sides and get rid of all the dust and grime and debris, but that should now be fine. Whether it works or not, we don't know yet. So make sure we don't trap any wires as we fit this. Okay, that's the entire drive reassembled. Make sure nothing's catching or binding. I'll check down between the board and the chassis to make sure that none of the wires are trapped. Okay, and that's that drive done. So as you can see, it looks a lot better, a lot cleaner, engages correctly. So the next thing to do is get it fitted to the machine and see if it actually works. Okay, I have the drive fitted into the MDS. It's all connected up, power's connected, I've got the ribbon cable connected, I've checked the configuration. Now we've got no way of knowing if these work, of course. They've been sitting around for a long time. Disk drives are normally fairly reliable, but it kind of depends on the treatment they've had and of course whether they work when the unit was put into storage. So we'll go through, restart the diagnostics, so we'll use the onboard diagnostics and run through the floppy drive test routine and see what results we get. Okay, so I've got a scratch disk installed in a drive. The drive needs that for the test because it tries to write data to each track and then read it back. So I'll boot up the MDS. It's in diagnostic mode, so we've heard the 5 beeps. And so what I'll do now is get us through the part of the test routine up to the point where I can start the floppy drive test. So as you can see, we've got through the first part of the diagnostics. Now if you watch the previous video, you'll know that we had a failure in part of this test, and that turned out to be a fault with the keyboard. It wasn't correctly sending the characters through to the IOC card. It's just a broken wire on the connector inside the connector shell, so I've repaired that, and as you can see we're now getting right through this part of the diagnostic. And so I'll start the disk test. So we heard the head engage, the drive light has come on. I can hear the drive moving through each track. It is a bit strange on this machine in that the drive spins all the time, so all the time the mains is powered up, the disk is actually spinning as long as the drive door is closed. Okay, so we have a failure. That is, let's check that one, that's a disk seek error. So these errors, they're bit coded. There's a table in the user manual or the service manual that says what each bit means, and that's a seek error. That's not a particularly useful error, it just means that it didn't work. And although it's saying seek error, I think that just means it can't read back the data that it's written. Okay, I'll try running it again just to make sure it wasn't just a single failure. So we definitely have the drive hooked up correctly, power's all there, otherwise it wouldn't be engaging the head and it wouldn't be getting this far. Just let it finish the test. And as you can see, we're still getting the same error. Okay, so what we'll do is we'll get the scope out and start investigating the problem with the drive. So when you encounter something like this, of course the question is where to start searching. It's a very complex machine, and just because the drive isn't reading anything doesn't necessarily mean that it's a fault with the drive itself. But because I've fairly thoroughly tested the rest of the machine, and I have carried out a lot of testing that I haven't yet shown on camera, I'm fairly confident that the problem does lie within the drive. I may be proven wrong, but that's the basis on which I'm going to proceed at this point. So the way I start with drives is generally always the same, or at least with this type of drive. So these drives are very common in this old type of equipment. I see probably 20 or 30 of these a year. They're fairly reliable. It's mostly mechanical things that we have issues with, and mostly bearings and broken hinges, that sort of thing. Do get problems with electronics, and unfortunately some of them are quite difficult to fix because of the rarity of some of the parts, but hopefully we'll be lucky with this one. But I'm going to start by checking the read-write head. It's the easiest thing to do. I've powered the machine off. Not quite sure if you can see the test meter or not. It's quite difficult to get the camera in a suitable place here because the MDS is so tall. But what we should have, again the standard connections for this particular drive on these heads, we should get low resistance, so 15 ohms, which is about right, and 22. This one should be open, it's a screen, and this one should be low as well. So okay, good. It looks like the head is at least reading okay in terms of its resistance. All the coils seem to be intact. So I'll get the scope up on top of the MDS and we'll start looking at the signals. Okay, I'm hoping you're going to be able to see all this okay. It's very difficult getting the camera in a suitable position where I can get everything into the shot. But I've got the scope sitting on top of the MDS. I've restarted the MDS and I've taken it through the onboard diagnostics to the point where I can start the floppy drive test. And the first thing I want to do is see if there's anything coming out of the read-write head in terms of the signal. So I'm just going to attach the scope to one of the test points. Luckily on this particular drive the test points are all nicely arranged. There's more than one version of this board and they're quite similar. The main thing that's different is just the layout of the components. This is the nice one, they're all laid out in an orderly fashion, but the other version of this board that uses the large-scale integration devices is a bit of a mess in terms of layout, and the test points are all over the place. But this one's quite nice. Now what we should see at this point is some modulated signal coming out of the drive. So the point I'm monitoring is pretty much the output of the read-write head. So we should see quite a decent signal coming out of it. It's actually quite a bit bigger than you might expect. It's usually 150 to 200 millivolts. So I'll start that running. I'll start the test again. And as we can see, we're getting a signal out of that side, and it's a dual-sided head. So when I say dual-sided, I mean there are two coils in it. It's a single-sided disc on this drive, but the coil is kind of a push-pull arrangement in terms of the way it's constructed. The head's moving towards the centre of the disc, so the disc is going slower past the head at this point, and you can see the signal is getting accordingly smaller. So starting on the outside, you see a nice big signal, and as the head progresses towards the centre, signal drops off. But as long as we're up around 100, 120 millivolts, that should be fine. So the signal certainly looks to be strong enough. And the next thing I want to look at is the data going into the first of two custom ICs. Unfortunately, these drives use a couple of custom devices that the manufacturer made. One's for the initial amplification of the signal coming from the read-write head, and the other one is to modulate data going to the read-write head. So I'll look at the signal coming out of the read-write section first. That's these two devices here. The top one is for reading the signal coming out of the read-write head, and the bottom one is to modulate data being written back to the read-write head. So we'll look at the output pin to start with, and then I'll restart the test. Okay, that doesn't really look right. It should be a fairly consistent, repeatable pattern that we're seeing, and it does look more like noise. Okay, so it's doing something, but I think that might be noise. What you can do is unplug the head and see if you get the same thing. Getting the same thing, then also the noise isn't coming from the read-write head. It doesn't look quite right, so I'll restart the test. And sure enough, we're seeing the same thing. So that's just noise. It's a very sensitive circuit, and if it's picking up noise rather than actual signal from the disk, then you'll still see what appears to be data. And because we know that we're getting quite strong signals from the disk, what we might have here is a problem with the read-write side of things. So I'll just reattach the read-write head. Carefully, if you do this with it switched on, you can damage things if you get it wrong. And so what we'll look at now is the modulation side. It looks like there is actually capability within that device to pick up the signal going in. It's certainly picking up noise very easily, but if data's not been written to the disk, then of course we're not going to get anything out of it. So the next thing I want to do is look at the data coming out of the modulation chip. So we'll look at this. I'll restart the test. Okay, we are getting a signal, but we're not getting any modulation. There should be modulation superimposed on this signal. So this is basically putting a DC bias through the head, but it should be modulated. So if we look directly at the read-write head, and I'll restart the test. Okay, so there's no modulation coming through to the read-write head. We'll just quickly check to see if we're getting gating going to the IC. Which we are, so that's the gating signal, and the modulation signal is also present. So it looks like the inputs to the device are correct, but there is nothing coming out. Let's check the erase signal as well. Again, that's fine. So it looks like the problem might well be in this device. It doesn't appear to be modulating the data going to the read-write head. What I will do, I've got a drive that I know works, slightly different type. It's the same drive but the other version of this board. I'll swap that out. I haven't restored it yet, so it's a bit dirty and messy, and it does need a lot of work, but I know that it will actually read the disk, so that will enable us to narrow down what's going on here. We could do more extensive testing and start looking more into the control electronics, but if we're not getting modulation despite the signal gating and signal data signals being present, then chances are we have a faulty custom chip. But I'll swap out the drive and show you what I mean by the fact we're not getting modulation going to the head. I've swapped the floppy drive out for one that I know works. I don't want to run it for too long because the bearings on this need changing, and if I leave it running it could well damage something. But I do know the electronics works. It's a slightly different version of the drive. The mechanics are pretty much identical and the circuit's very similar, just a different physical layout of the board. But what I want to demonstrate is what I mean by modulation at the read-write head. So if I connect the scope to the same point we were monitoring previously, and I'll now start the test again, you'll see the modulation superimposed on the signal that we previously saw. So as you can see, it's a very dirty drive, so the connections aren't too good. But as you can see, there is clear modulation on the data, and that's what we should be seeing on the other drive. When you write data to a magnetic media like tape or floppy disk, it's not just written as a DC value, it's written as a modulated signal, and that way the data is more reliably recorded on the media, because of course the media can't really store constant values. It can only really reliably store transitions, and so that's the way that the data is stored, as a series of transitions, and hence the need to modulate it. So I'll run it one more time, and you can see the modulation, and that's what's missing from the other drive. And this modulation is created or generated by the IC I was talking about on the other drive, and that's why I suspect it's the IC that's faulty. The only real way to test it beyond the point that I have is to substitute it with a new one, and we can see now these pulses are the drive being read, and you can see it's a modulated signal that we are getting. Okay, so now that we've seen what the signal should look like, I'll move the camera back round to the front of the MDS and see if the test actually succeeds. So looking at the screen of the MDS again, you can see that the test passed. I'll just rerun it to be sure it passes each time. So we can see that the drive light has come on, the test is underway, and you can possibly hear the drive doing its thing over the noise of the fans. So I'll wait until the test is finished. And as we can see, the test passes. So this means that the MDS can now read from floppy drive. I still need to repair the other floppy drive, of course, and I also need to restore this one along with several others that also don't work. But what we'll do now is, just for a bit of fun, is we'll try and boot the MDS from a floppy disk. So I'll just grab the Intel operating system disk and see if it will boot. Okay, so we'll pop this disk out. Insert the system boot disk. I'll move the diagnostic switch back to its run position. And now if I reset the machine, it should boot from floppy. And as you can see, it's booted to the ISIS operating system. So that's a good step forward. It means that this MDS unit is now starting to come to life. As I say, we need to fix its floppy disk drive, but we can now see it's running. It won't run all the functions that we want to test because we don't have all the cards plugged in yet. But it will run like this. This is all really you need for a minimal MDS system. And to give you an idea that the operating system is actually running, I shall do a listing of the disk we currently have in. And you can see we're showing the contents of that particular disk. So as you can see, the system is running. It can access the floppy drive. Can't access its own floppy drive yet, but as I say, we'll need to get that one repaired. But once that's been repaired and I swap out this drive, then this unit is ready for some more thorough testing. This incidentally is why I go to so much time and trouble with each of the cards before I start plugging them in. Otherwise we could spend an awful lot of time trying to figure out why the disk drive wouldn't work. Of course the fault could have been in one of many places, but because we tested all the cards, all the power supplies, memory, etc., then it was fairly easy to narrow it down to the drive itself. Okay, so that's it for this video. In the next one we'll try and figure out what's wrong with the floppy drive and get it repaired.